Hello बच्चों, let's read the question. Let fx is equal to x squared times cos of 1 by x for values of x less than 0, 0 when x is equal to 0, x squared times sine of 1 by x when x is greater than 0. Then which of the following is correct? Are correct? Option A, fx is continuous but not differentiable at x equal to 0. Option B, fx is continuous and differentiable at x equal to 0. Option C, f prime is continuous but not differentiable at x equal to 0. And option D is f prime x is discontinuous at x equal to 0. Solution start करने से पहले let's note down the key concepts for this problem. So the key concepts are definition for continuity and differentiability. So a function f is said to be continuous at point x equal to a if limit x tends to a, fx is equal to f of a. And the second definition we have is a function f is said to be differentiable at a point x equals a only if limit x tends to a, fx minus f of a divided by x minus a exists and the derivative of the function at point a is equal to the limit x tends to a, fx minus fa divided by x minus a. So the value of the limit is the derivative of f at x equals a. Now let's start with the solution. Since we have the function fx as x squared times cos of 1 by x for values of x less than 0, 0 for x equal to 0 and x squared times sine of 1 by x for x greater than 0. So let's check continuity of fx. So we have limit x tends to 0 minus of f of x is equal to limit x tends to 0 minus of x squared times cos of 1 divided by x. Now to evaluate this limit, understand that mod of cos of 1 by x is less than equal to 1, which implies cos of 1 divided by x is less than equal is lying between minus 1 and 1. If we multiply by x squared throughout, so we have minus of x squared times 1, so we have minus of x squared times 1 less than equal to x squared times cos of 1 divided by x less than equal to x squared. And if we take limit x tends to 0 throughout, so we will have 0 less than equal to limit x tends to 0 x squared times cos of 1 divided by x less than equal to 0. So as you can see, by sandwich theorem, you can therefore say that limit x tends to 0 x squared times cos of 1 divided by x is equal to 0. This is by sandwich theorem. So here this is equal to 0. Now let's check limit x tends to 0 plus of fx. So this is equal to limit x tends to 0 plus of x squared times sine of 1 divided by x. Again understand that sine of 1 by x, mod of sine of 1 by x is less than equal to 1. And similarly with the same procedure, you can therefore say the limit x squared times sine of 1 by x as x goes to 0 is equal to 0. And so therefore limit x tends to 0 of fx is equal to 0, which is equal to f of 0. And so therefore f of x is continuous at x equals 0. Now let's talk about differentiability of function fx. To check differentiability, we have to use the definition. So limit x tends to 0 minus of fx minus f of 0 divided by x minus 0 equals limit x tends to 0 minus of fx. So as x is less than 0, so the function fx defined as x squared times cos of 1 divided by x minus 0 divided by x. So this simplifies to limit x tends to 0 minus of x times cos of 1 divided by x. Now again understand that mod of cos of 1 divided by x is less than equal to 1, and so therefore we have, if we open up the modulus, so we have minus 1 less than equal to cos of 1 divided by x less than equal to 1. Multiplying by x throughout, so we get minus x less than equal to x times cos of 1 divided by x less than equal to x. Now let's take limit x tends to 0 throughout, so we have 0 less than equal to limit x tends to 0 x times cos of 1 divided by x less than equal to 0. So therefore by sandwich theorem we have limit x tends to 0 x times cos of 1 divided by x equals 0. So this limit is 0. Now let's calculate the right hand limit. So we limit x tends to 0 plus fx minus f of 0 divided by x minus 0 equals limit x tends to 0 minus of x squared times sine of 1 divided by x minus 0 divided by x. So this is equal to limit x tends to 0 minus of x times sine of 1 divided by x divided by 1. So understand that modulus of sine of 1 divided by x is less than equal to 1. That is, sine function is bounded, right? So whenever we have a bounded function multiplied by the variable which is going to 0, the limiting value is therefore equal to 0. And this is a short proof of how to prove that statement by using sandwich theorem. And so therefore we have limit x tends to 0 of fx minus f of 0 divided by x minus 0 equal to 0. And so therefore we say that function f is differentiable at x equals to 0 and f dash at 0 is equal to 0. Now let's check continuity and differentiability of f prime of x. Firstly, let's write explicitly f prime of x. So we have f prime of x equal to 2x times cos of 1 divided by x plus squared divided by x squared sine of 1 divided by x for values of x less than 0, and f prime of x is equal to 0 when x is equal to 0, and we have f prime of x as 2x sine of 1 divided by x minus cos of 1 divided by x for values of x greater than 0. Now let's check the continuity for f prime of x. To check the continuity, first we have to see whether the limits exist. So first we have limit x tends to 0 minus of f prime of x is equal to limit x tends to 0 minus of 2x times cos of 1 divided by x plus sine of 1 divided by x. Now understand that the limit of this part is 0, but the limit as x tends to 0, sine of 1 by x is not defined because it oscillates, and so therefore the overall limit is not defined, i.e. that is does not exist. Now let's evaluate the right hand limit. So we have limit x tends to 0 plus of f prime of x equal limit x tends to 0 plus of 2x times sine of 1 divided by x minus cos of 1 divided by x. Here again this limit is 0, but this part is not defined. Limit is not defined. So therefore the overall limit is not defined. That is, does not exist. And since the limits are not existing, therefore the function f dash x is not continuous at x equals to 0, and therefore f prime of x is not differentiable at x equals to 0. Now let's check the options. So among the options, option A, fx is continuous but not differentiable, is incorrect. Fx is continuous and differentiable at x equals to 0 is true. F prime is continuous but not differentiable at x equal to 0, false, incorrect. And option D, f dash x, f prime is discontinuous at x equal to 0, true. So B and D are the correct options. I hope you understood it well. Best of luck and thank you.